Visible, Muniba?
Yes, ma'am.
So we have started with the solution chapter, right? So we have completed the concentration terms, the different types of different ways by which we can find the concentration, right? Molality, your mole fraction, right, etc. And today we are going to start with the solubility, right? So we have just done with the relationship between molarity and molality. We just derived the formula, right? This formula by which we can find the molarity and molality, right? First, tell me why you guys don't submit your homework, Muniba and Jupiter. अभी तक आपने सबमिट नहीं किया होमवर्क, why?
Ma'am, which one?
Yes, I've given
Ma'am,
you home. I've given you homework in the last class.
ma'am, from Tuesday onwards I was a little bit busy because we went to Hajj. We went to Dammam, that's why.
Okay, no problem. So please do it ASAP
Yeah.
and just
Ready.
submit it. Okay, submit it by before the next class. Because
Okay.
आप होमवर्क नहीं करोगे, आप पेंडिंग चला जाएगा and next homework आपको मिलता रहेगा, right? So it's
Okay.
better कि do the homework in the same class, right?
Okay.
After the class, just revise the whole concept, whole notes, and then do the question. Okay,
Okay.
अगर question नहीं solve होते, then ask me in the next class. Okay, and what about yours, Muniba?
Ma'am, I have exams coming up, so like I was busy with them, and I didn't really pay attention to completing it.
Okay, so is this chapter coming in your exam? Solution
Yes,
chapter? Okay, so वो exams की preparation होगी, आप जब question solve करोगे तो it's better for you, right?
yes, ma'am, I'll complete it.
Yeah. So वैसे भी मैं ज़्यादा questions नहीं देती हूँ, 3 to 4 questions, right? It will take half an hour to do these questions, not much more than that. Okay. So I have given these questions in your homework. So you will do that homework first. If there is any doubt in this question, then I will explain it to you. So today I'm starting with the solubility. Okay. So solubility. So what is solubility? So solubility, it is basically the amount of substance that can be dissolved in a fixed amount of solvent at a given temperature, right? At a particular temperature, at a given temperature, the amount of uh, how much substance is dissolved in a fixed amount of solvent, that is your solubility, right? ये क्या होता है? Solubility. So that's a proper definition of solubility. Now, what are the factors which affects the solubility of solids in liquids? Okay, we will particular focus on solubility of solids in liquids. So, what are the factors which affect the solubility? So, there are three factors, right? Three factors which affects the solubility of solids in liquid. First factor is the nature of solute and solvent, right? Means of what is the nature of solute? Is it polar or is it non-polar, right? What is the nature of solvent? So it depends on that. And what is the general rule? So the nature of solute and solvent, it depends on the general rule. General rule for solubility is like dissolves like, right? So like dissolves like. Right. So means what does this mean? Like dissolves like means the polar dissolves the polar molecules, right? And the non-polar dissolves the non-polar molecules, right? Polar dissolves means the solvent, if the solvent is polar in nature, then it dissolves the polar molecules in itself, right? Because like dissolves like. Okay. So polar dissolves polar molecules. Polar molecules. And your non-polar dissolves non-polar molecules. Right, so you just have to remember this rule, general rule for solubility, which means like dissolves like. If the solute is polar, then if the solvent is polar, then it will dissolve the polar molecules only, right? And if the solvent is non-polar in nature, then it will dissolve non-polar molecules, right? It's the first factor is that nature of solute and solvent. Now see, the second factor is your pressure, right? So second is your pressure. So it has, because it's a solid in liquid type of solution, solid and liquid type of solution. So the pressure has no effect. It has no effect on solids, right? Why? Because solids are rigid. Solids are rigid. They are compactly packed, right? They are compactly packed. So the on increasing or decreasing pressure, it doesn't affect the solid, right? It doesn't affect the solid. So pressure का कोई भी effect नहीं होता solids. Just remember that, right? Third, third factor is your temperature, right? Temperature. Now see, dissolution is endothermic. If the dissolution, if अगर आप solid and liquid को dissolve करें, if you are dissolving solid into liquid, and that dissolution is endothermic. Okay, do you know what is endothermic and what is exothermic? Jyobita and Muniba, what is endothermic, बच्चे?
Less heat.
Yes, less heat, right? Means in endothermic, it absorb the thermal energy, right? It absorb the thermal energy from the surrounding, right? Causing the surrounding cool, right? When it absorb the thermal energy from the surrounding, तो क्या होगा? Surrounding जो होगा वो cool down हो जाएगा, right? Means the energy is transferred into the system, right? Endothermic is what? Energy is transferred into the system from the environment, right? From the environment. Means if energy is transferred into the system from the environment, so the temperature will decrease, right? The temperature will decrease, and if the temperature will decrease, the solubility increases, right? Solubility increases because solubility and temperature, it has an inverse relationship, right? Temperature decreases, solubility increases. Next is your dissolution is exothermic. If the dissolution is exothermic, what will happen? The temperature will increase, right? What do you mean by exothermic? So exothermic means it releases thermal energy, means heat, into the surrounding, right? And if it releases thermal energy, then the temperature will increase, right? Then the temperature will increase. Okay, just a second, just a second. I think it's wrong. Dissolution is exothermic, means if the temperature increases, temperature अगर increase होगा, then solubility also increases, right? And in endothermic, if the temperature decreases, solubility also decreases. Okay, and the vice versa. Okay, so that's the factors that affect the solubility of solids in liquid. Okay, so there are three factors: nature of solute and solvent. You just have to remember the general rule for solubility, means the like dissolves like, right? And the
Ma'am,
pressure, yes,
in exothermic reaction, if the temperature increases, solubility decreases, right?
yeah, yeah. In exothermic reaction, yeah, मैंने जो पहले लिखा था, that's the correct. In exothermic reaction, Yes, Maniba. Okay, just tell me.
Temperature will increase, so solubility will decrease.
Yes. Yes. Yeah. Okay, that's the correct जो मैंने पहले लिखा था. That's correct. And in endothermic is just opposite, right? In endothermic, what happens? The temperature will increase or decrease. So in endothermic, the temperature, if it decreases, the solubility increases. Okay. So please
Solubility will also decrease, right?
just a second. Yes, Vachin. Yeah. Now please just write it down. The definition of solubility and the factors affecting the solubility of solids in liquids. Written? So it's a solid and liquid type of solution, right? So in this case, basically, the temperature is directly proportional to solubility, right? In the most of the cases, increasing the temperature of the solvent, right? We are discussing according to the solvent, right? So if the solvent temperature increases, so it leads to the increase in solubility, right? तो यहाँ पे देखो in the case of endothermic reaction, right? So in the case of endothermic reaction, when the temperature is increases, right? क्योंकि इस surrounding का तो temperature decrease हो रहा है, but उस particular system का temperature increase हो रहा है, right? In the type of endothermic type of dissolution, right? So the system absorb more heat. System क्या कर रहा है? More heat absorb कर रहा है. So the dissolution process, it leads to the higher solubility, right? It leads to the higher solubility in the case of endothermic. There's a little bit confusion here, just confusion. Let's clear it. So in the In the case of endothermic reaction, what happens? Because energy is transferred into the system from the environment, right? तो from the environment से really energy absorb हुआ, तो environment का तो energy temperature कम हो रहा है, but your system की energy increase हो रही है, right? System की energy increase हो रही है, and we are talking about the system, right? So we are talking about the system. If the temperature increases, we are talking about the system, right? So temperature is increases, right? Temperature increase हो रहा है, तो system is absorbing heat, right? System अगर absorb कर रहा है heat, तो obviously उसकी temperature increase होगी, right? So in this case also, the dissolution increases. Dissolution increases means the solubility increases. It's very simple. जब आप क्या करते हो, when you make the solution like sodium chloride and water solution, right? So it's a solid and liquid type of solution. तो जब आपका डिजोल्व नहीं होता है, तो यू विल जस्ट हीट. जब आप उसे टेम्परेचर देते हो, हीट करते हो, तो वो क्वाइट वो डिजोल्व होने लगता है, मीन्स उसकी सॉलिबिलिटी इंक्रीज हो जाती है, राइट? तो इट्स वेरी सिंपल, मीन्स यू आर जस्ट इंक्रीजिंग द टेम्परेचर. On increasing temperature, the solubility increases. Now clear, Giovita and Muniba?
Yes, ma'am.
Now see, in exothermic reaction, because in this case, increase in temperature would initially favor the reverse reaction. यहाँ पे क्या होगा? रिवर्स रिएक्शन होगा, जिसकी वजह से लोअर सॉलिबिलिटी हो जाएगी. यहाँ पे क्या होगा? एक्सोथर्मिक के केस में, क्योंकि एब्जॉर्ब यहाँ पे रिलीज हो रही है, राइट? एक्सोथर्मिक के केस में क्या हो रहा है? रिलीज, इट रिलीजेस अ थर्मल एनर्जी इनटू द सराउंड. उस सिस्टम का टेम्परेचर तो डिक्रीज हो रहा है, बट द एनवायरमेंट का टेम्परेचर इंक्रीज हो रहा है, right? Means the energy is transferred from the system to the environment, right? तो उस सिस्टम का तो एनर्जी कम हो रहा है, टेम्परेचर कम हो रहा है, बट द एनवायरमेंट की टेम्परेचर इंक्रीज हो रहा है, right? So in this case, the solubility decreases. Clear?
Yes.
Have you guys written?
Yes, ma'am.
So let's do one question. The question is on dissolving ammonium chloride in water at room temperature. The solution feels cool to touch. Cool to touch. Under which of the following conditions does the salt dissolve faster? Right. So first is the question is on dissolving ammonium chloride. Right. You are dissolving ammonium chloride in water. Right. At what temperature? So at room temperature. The solution feels cool to touch. Right. जब उसे आप टच करोगे, उस vehicle को टच करोगे, तो it feels like cool, cooling feeling को देगा. So under which of the following conditions does salt dissolve faster? Options are, first option is powdered salt in cold water. Second is powdered salt in hot water. Salt crystals in cold water. D option is salt crystals in hot water. Which option will be correct?
Second.
Yeah, it's second. Very good. Right, because we know that on increasing temperature, the solubility increases. So it's the powdered salt in hot water. Right, so the second option is correct. Clear, both of you? Okay. And next is your factors affecting the solubility of gas and liquid. Right, so we have just discussed the solubility factors affecting the solubility of solids and liquid. Now the topic is the factors affecting the solubility of gas and liquid. Right. So first is your temperature. Now in this case, the solubility is inversely proportional to temperature. Right. इसकी वजह से confusion create हुआ था, right? Because it's a solubility of gas and liquid, not solid and liquid. Right. So just remember the temperature is inversely proportional to solubility in the case of solubility of gas and liquid, right? If the liquid is gas, if the solution is gas and liquid type of solution, then in this case the temperature is inversely proportional to solubility. If you are increasing temperature, then the solubility will decrease and vice versa. Like in the case of cold drink. कि कोल्ड ड्रिंक के केस में आप उसे कूल क्यों रखते हो, उसे ठंडा क्यों रखते हो? ड्यू टू दिस, because if you are cooling, if you are decreasing temperature, the solubility increases, right? Because that's a gas and liquid type of solution, right? Cold drink is what it is, example of gas and liquid type of solution. Here the carbonic acid is there, right? Carbon dioxide is filled in the cold drink bottle. That's why the temperature is decreasing. Temperature हम decrease करके रखते हैं. We just refrigerate it. Fridge में हम cool करके रखते हैं cold drink को, right? So why? Because to increase the solubility of that cold drink, right? जो गैस का जो solubility उसमें जो carbon dioxide गैस है वो soluble रहे. That's why भी हम उसे cool down करके रखते हैं. उसे temperature decrease करके रखते हैं, right? That's the best example of this. Okay, so the nature of, again, the factors affecting the solubility of gas and liquid, it depends on the nature of solute and solvent, right? First, you can yeah, it also depends on the nature of solute and solvent. Again, the same rule, general rule, that is like dissolves like, right? Most important is the temperature, right? If you are increasing temperature, the solubility will decrease and vice versa in the case of gas and liquid type of solution. Clear?
Yes.
Yes.
The difference. Okay. Solid के केस में directly proportional होता है, but in the case of gas and liquid type of solution, it's inversely proportional to temperature. Now here's a question that why aquatic animals are more comfortable in cold water than in warm water? Do you know the reason?
Because more oxygen is dissolved in cold water than warm water.
Yeah, right. Because in lower temperature, because in cold water, the solubility of oxygen is higher than the warm water, right? Because we know that solubility is inversely proportional to temperature. Temperature अगर कम होगा तो solubility ज़्यादा होगी. That's why in cold water, the solubility of oxygen is more than that in the warm water, right? That's why aquatic animals are more comfortable in cold water. Yeah. So इस type के questions अगर आए तो you can just explain it. You can give the reason. And you can just say that solubility is inversely proportional to temperature. So in cold water, in lower temperature, the solubility of oxygen is higher than in warm water. That's why they are more comfortable. Okay. So you can write it by yourself. Is there need to write the answer, Moniba and Giobita? Yes, Moniba and Giobita. Is there
No, ma'am.
need to write down the answer? Okay, you can explain it by yourself. Yeah. Okay. Third factor is the pressure, right? Third factor is the pressure. And solubility is directly proportional to pressure, right? So if the solubility of gas at a given temperature, it is directly proportional to the pressure at which it is added, right? So just remember, if you are increasing pressure, the solubility also decreases. Sorry, increases. Right? Because it's directly proportional to pressure. Okay, just write it from here. The factors affecting the solubility of gas and liquid. Done?
Yeah.
Clear now?
Yes, ma'am.
So these are the factors on which the solubility of gas and liquid depends. Next is very important, which is Henry's law. So what is Henry's law? So it's Henry's law states that partial pressure of a gas in vapor phase is directly proportional to the mole fraction of gas in solution. Right? So what does Henry law state? So it states that partial pressure of any gas in a vapor phase, it must be in vapor phase, they are directly proportional to the mole fraction of gas in the solution. Right? So this P is directly proportional to XP. This is the mole fraction of gas in a solution. Mole fraction of gas. Gas here is solute. Solute particles. B is solute particles. Right? So if you remove this proportionality sign, so here this proportional constant will be there. It, what is KH? Where KH is your Henry's constant. Your Henry's constant. Okay, so that's the relationship between the partial pressure of a gas in vapor phase. It is directly proportional to mole fraction, right? If the mole fraction of your solute particles, which is gas here, right? This is gas here. It is again a gas and liquid type of solution. Okay, so gas particles के mole fraction पे depend करता है partial pressure of gas, right? It's directly proportional. And P is equals to KH into XP. This is very important relationship. P, this is partial pressure of gas, is equals to the Henry's constant into the mole fraction of B. B क्या है यहाँ पे? It's the solute particles. Solute particles, which is the gas particle. Here, so that's the Henry's law. Now Henry's constant, KH. So KH is what? KH is a function of gas, which meaning that different gas have different value of KH. Right? Different gases have different value of K. Henry's constant value. Right? Now see, KH, KH, KH tells us, it tells about escaping tendency. Escaping tendency of a gas. Right? This KH, Henry's constant, it tells us about the escaping tendency. Now, what is escaping tendency? So, escaping tendency means it is a measure of how readily a gas will leave. Right? कितना जल्दी वो गैस उस सॉल्यूशन से escape करेगा, लीव करेगा, right? From a given phase. What is escaping tendency? So escaping tendency is a measure of how readily a gas will leave or escape from a given phase or state. That's escaping tendency, right? So this Henry's constant, it tells us about the escape tendency of any gas, right? That's why every gas has its own escaping tendency, right? Every gas has different value of Henry's constant, right? Because their escaping tendency are different. That's why they have different value of Henry's constant. Clear? Muniba and Jubita?
Yeah.
Yes, ma'am.
Okay, now see what is the unit of Henry's constant. So we know that P is equals to Kh into Xp, right? Henry's constant into mole fraction of B, right? So from here, Kh is equals to P upon Xp. Kh will be, Henry's constant will be partial pressure of a gas divided by the mole fraction of B, mole fraction of your solute particles, right? Now see, for unit, we are just deriving the unit. So partial pressure, so it's a pressure. So इसका unit क्या होगा? It may be ATM, bar, or Pascal, right? This may be the unit of partial pressure. And this is mole fraction. And we know that mole fraction is, it's a fraction, so it is a unitless. It is unitless. So what will be the unit of your Henry's constant? So it is just equal to the unit of partial pressure, which is ATM, right? Atmospheric pressure, or bar, or Pascal, or mm of Hg, right? So this is the unit of Henry's constant. Now see the relationship between temperature, solubility, and Henry's constant. This is very important, right? So see, Henry's constant is directly proportional to temperature, right? Henry's constant is directly proportional to temperature. Means if the temperature is increases, the Henry's constant also increases, right? And we know that temperature of a gas is inversely proportional to solubility, right? Temperature, I'm just talking about the gas and liquid type of solution. So temperature is inversely proportional to solubility, right? So we can just substitute it over here. So Kh means Henry's constant is inversely proportional to solubility, right? So this is the relationship between these three. Temperature, if you increase the temperature, the solubility will decrease and your Henry's constant will increase. Because temperature is directly proportional to Henry's constant, so it will increase, and the temperature is inversely proportional to solubility. So on increasing temperature, the solubility automatically it decreases. Clear till here? Any doubt?
No, no.
Jyobita, any doubt, bache?
No, ma'am.
Okay, so just write it down. The Henry's constant from here. Done?
Yes, ma'am.
Okay, see this question. Gas A is more soluble in water than gas B, right? So at the same temperature, the temperature is same. Which one of the two gases will have the higher value of Henry's constant and why? Okay, so so in question, what is given? Gas A according to solubility. Solubility. Right, so gas A is more soluble in water than gas B, right? So what will be the Henry's constant? Right, which two gases have more Henry's constant value, higher Henry's constant value? Yes, Jyotika
Gas
and
B.
Monica? Yeah, gas B. Why?
Because the Henry's constant increases with the decrease of solubility.
Yes, right. It means they have inverse relationship, right? So the solubility, what is the relationship? Solubility is inversely proportional to Henry's constant, right? So which gas has more solubility? Gas A has more solubility, so it has less Henry's constant value, right? So KH, so gas A has less Henry's constant value than gas B, right? And why you know very well? Because they have a inverse relationship. Okay. See the next
Yes, ma'am.
question. pH values for these gases, argon, carbon dioxide, SCHO, right? CH4 are these. These are the pH Henry's constant values for these gases, right? Arrange these gases in order of increasing solubility, right? Just do the question and just tell me with reason. pH values are given for these gases. You just have to tell me the solubility, right? On the basis of the increasing order of solubility. Remember if the pH value is higher, then the solubility will be lower for that gas. For carbon dioxide, it is 1.67. The other values of pH and response. For carbon dioxide, for HCHO, as formaldehyde, it's 1.83 into 10 to the power minus. Right, so it's 10 to the minus 5 means 1.83 upon 10 to the power 1, 2, 3, 4, 5. Right, so it's 0.00000183. Right, and for methane, it's 0.143. Now, these are the pH values. So just arrange it. So which has more pH value? So argon has the highest pH value, right? After argon has highest. After argon, which has the carbon dioxide, is 1.67. After this, CH4, methane, and after methane, carbon. Right? That's the order of Henry's constant of different gases. Now, according to the solubility, increasing order of solubility, just arrange it. Right? See, argon has the highest pH value. right? So it must have the lowest solubility, right? Lowest solubility, just write it down. Lowest. After this CO2, after this CH4, after this SCH, right? Means the lowest pH value has the highest solubility, right? The gas which has the lowest value of pH has the highest value of solubility, right? So formaldehyde, it is the highest. So which option is correct? To see your option C is correct, right? Option C is correct. Clear, both of you, Jovita and Muniba?
Yes, ma'am.
Yes, ma'am.
Okay. Write down the solution. Done?
Yes, ma'am.
Let's see this question. State Henry's law. Calculate the mole fraction of carbon dioxide in water at 298 Kelvin under 760 mm of Hg. Right? And Henry's constant for carbon dioxide in water is given, which is 1.25 into 10 to the power 6 mm of Hg. Right? So how to do this question? How to first just state the Henry's law. You know very well what is Henry's law. So as we have discussed it over here, what is Henry's law? So if this type of question came in your exam, so you have to just write down the definition, the statement, statement with these mathematical, right? With this formula, P is directly proportional to mole fraction of B and P is equals to KH into X. So till here, आपको ये पूरा mention करना है in your exam. Okay, so that's the Henry's law. That's how you can just explain or state the Henry's law. Now the second question, calculate the mole fraction of carbon dioxide in water at 298 Kelvin under this pressure. Right. So how to calculate this? See, we know the relationship P is equals to Henry's constant into your mole fraction of B. Right. Now we know that the mole from here you can just calculate the mole fraction of B. Mole fraction of B is equals to pressure, partial pressure upon Henry's constant. Now see the value of pressure and Henry's constant for carbon dioxide is given. Okay, now just substitute it in the question in this formula. So pressure is 760 mmHg. And what is the Henry's constant value for carbon dioxide? So it's 1.25 into 10 to the power 6 mm of Hg. Right. So you can see both units are same. So it will cancel out. Right. And this 760 upon this. So when you solve this, so 760 upon, so this decimal will comes here 10 to the power 2 upon this 125 into 10 to the power 6 into 10 to the power, right? So it will give you 760 upon 125 into 10 to the power minus, yeah, यहाँ से 2 power and from here 2 power will cancel out and 10 to the power 4. right? It will goes here by giving the value of exponential from 10 to the power minus 4, right? Now just solve it. Divide 760 divided by 125. 760 divided by 125. So it's okay. Okay, so it's 125 and the 125, it's 6. So 6 into 10 to the power minus. That's the value of mole fraction. Mole fraction of carbon dioxide is 6 into 10 to the power minus. Right? It's a mole fraction, so it has no unit. Clear? Is there any doubt in any step, Jabita and Maniba?
Ma'am, the final answer is 6.08.
6. What? 6 into 10 to the power minus 4. Approximate value.
125 into 6 is 750, not 760.
Just a second. It's 760 upon 125, right? And this decimal goes over here, 10 to the power 2. These will cancel out. Yeah. The final answer will be 6 into 10 to the power 4 minus 4. Yes.
No, but 125 into 6 is 750. It's not 760.
Just a second. Okay, just a second. There's a calculation mistake. 760 upon 125 into 10 to the power minus 4. Approximate 6 point. It will give you 7. When you divide 760, you can use calculator, bachche. 760 upon 125. So it's approximate value. It will give you 6.08. It will give you 6.08. The approximate value, you can just take 6 into 10 to the power minus 4. Right. यहाँ पे मैंने calculation mistake करी 760 था, it's not 760. It's just an approximate value. 6.0 something value आएगी, but you can just take approximate value. It's not exact value. In your exam, you can use approximate value also. No need to write down the exact value. You will get the full marks. अगर आप 6 into approximate लिखते हो 6 into 10 power minus 4, तो you will get the full marks. If you want to write down the exact value, so it will be 6.08 something into 10 to the power minus. This is written. Okay, see the graph for Henry's law. How to plot the graph for Henry's law. So we know that P is equals to KH, means Henry's constant, into the mole fraction. If you want to plot the graph between the partial pressure of gas and the mole fraction of gas, right? It's a P versus partial pressure versus mole fraction of gas, right? So you will get a straight line graph, right? It's a straight line graph, and the slope of this graph is equals to the Henry's constant. Slope will be equals to the Henry's constant, right? Now you can, if you want to plot the graph between partial pressure and the mole fraction of your solvent, right? This is the solute over here, B particle. XB is your solute, right? If you want to plot the graph between the partial pressure of a gas and the mole fraction of your solvent, so it will have this type of graph, decreasing order. How? So if P is equals to KH into XB, yeah, we know this relationship, and we know that for a binary solution, x mole fraction of A and mole fraction of B, the sum of these mole fraction is equals to 1, right? So can we substitute this? XB is equals to 1 minus XA, right? So XB is equals to mole fraction of solute is equals to 1 minus mole fraction of solvent, right? So just substitute it over here. KH is equals to P is equals to KH into 1 minus X, right? So you can see over here, this is P is equals to Y is equals to minus X. This is your minus MX plus C, right? तो ये कैसा ग्राफ है? बेसिकली आपका होता है y is equals to mx plus c. This type of graph, y is equals to mx type of graph is always a straight line. A straight line in a positive direction, this type of direction. This is the y equals to mx type of graph, right? And this is your downward. This type of decreasing order type of graph. So here you can see this is a minus mx plus c type of graph. Y is equals to minus mx plus c. So if this minus sign means this is a decreasing type of graph, right? And the slope for that, slope is always equals to minus h. Slope is equals to minus h, which is minus Henry's constant, right? So this is the graph for Henry's constant, the relationship, the partial pressure versus the mole fraction of solute, and the partial pressure versus the mole fraction of solvent. Okay, just remember these graphs. Just remember the slope. Slope is equals to KH, right? In the case of P versus XB, and is equals to slope is equals to always negative of Henry's constant, right? In the case of P versus XA means the mole fraction of solvent. Please draw the graph.
Done.